In this video, we're going to look at some more advanced ways that you can use Piper to augment your analysis and parsing directly within Burp using message viewers. So if you go to your Piper tab, and then that first tab, message viewers, is where you implement these, and we're just going to implement a few that process JavaScript in order to pull out what might be interesting or valuable information for us. So the first one here I have called AST strings. And the reason I've named it is because it uses a parsing tool to create an abstract syntax tree of JavaScript, and then we extract the string literals from that creation. So basically, it's a much superior alternative to using something like a regular expression to try and parse JavaScript in order to extract strings from it. And as you can see here, we just have a simple JavaScript response, and we have this Piper viewer, this Piper message viewer constructed to very simply just create that tree, pull out those strings, and print those for us. So if we're looking at a lot of JavaScript and we want to quickly identify the string literals within those JavaScript files directly within Burp, this is a simple trick that we can do. So let's look at the setup for this. So in Piper, I'll go over to the AST strings message viewer, I'll double click that. And if you look at the command and the filter is quite simple. We're just matching on application/JavaScript. That might not be a perfect filter, something to keep in mind. You might get broken, incorrect content type, whatever. You might want to change that. The command is specifying a shell script that we have by absolute path. And that, of course, you can see over on the left-hand side in my folder navigator is this aststrings.sh. So let's open this up and take a look. Ignore all of the commented off code here. We're just looking at this first part. So we're actually in the script, we're calling another script, and then we're running, we're then piping that output to JQ. And then we're essentially applying a filter to that, right? So the first script is creating our abstract syntax tree, and then we're sending that to JQ in order to just extract those strings that we might want. There probably is a better way to do it, but this is what we're doing here. And this is the thing with Piper. It gives us so much flexibility, and there's so many different ways to solve a problem. In fact, this video, I'm going to show you multiple different ways to solve this particular problem. But in this case, let's just look at this solution. So we're calling that script ast1.js, and this is just a node script right here that we're running. It uses the tool swc in order to create that abstract syntax tree. I'll post all of this code online so it's available if you're interested. But essentially, we're taking that tree, we're filtering it, and then we're just viewing that right inside of Burp. There's nothing more than that. So if I go back to repeater, you can see there it is in action. Isn't that handy? And of course, if we wanted to modify anything, because this is in a series of script files, we can just modify those easily here, or maybe preferably in whatever code editor you're using, without having to go through the workflow of editing that in Piper. Another thing you might want to do is extract comments from JavaScript. And I realize that SWC doesn't allow us to extract comments. So I used this other tool, ESPrima, I think it may be pronounced, which is just another parser for JavaScript or ECMAScript. And if I open that up, you can see that we have another node script that utilizes another dependency, this tool, in order to do that parsing. And then, of course, we have our shell script, which is this one, comments.sh. Which is quite simple, right? This one, in this case, is just calling that JavaScript file. I'll save this, sure. We'll get rid of those new lines. And if I go over to Piper and we look at the configuration for this js-comments, it's quite simple as well. We have the same filter for that content type, and then we're running our script and we're specifying the absolute path. It really is quite simple. So I go back to repeater, and we're on our JavaScript request, or rather our request that returns a response with JavaScript in it. And if I select JS comments, you can see, look at that, we have comments. And it was possible also to extract the lines for this, which was, I think, quite handy. So you could build in Again, you have limitless possibilities. You can build in little conveniences like that. Like if you have a very large JavaScript file or other types of data that you're analyzing, it might be helpful not just to pull out the data that you want to identify, but also to indicate where that appears, just to make it a little bit easier to navigate through it in its raw form. Of course, in our case, it's a very uninteresting JavaScript file. It's quite simple. Really nothing else to say. I wanted to demonstrate another security testing tool that also fulfills the same purpose. I have another video which I will link to the JS Loose tool, which is another tool that operates by using abstract syntax trees. Of course, it essentially acts as a wrapper around those and provides a number of capabilities geared towards security testing, like extracting secrets or URLs. But because it's a command line tool, it is yet another tool that we can use via Piper. So as you can see here, I have a viewer already set up for JS Loose, and just like the other commands, it's almost as simple. There's one little trick that I'll show you that might come in handy. So here we can see, again, we are looking at responses only. We are matching JavaScript content types, and I'm specifying the absolute path to that bash script that is stored on my system. Now let's go and take a quick look at the script. So this script does the exact same thing as my AST strings script that uses a different tool, a different parser for JavaScript, and a different process for extracting the string literals, and yet it produces the same results as JS Loose. See, look at that. Exactly the same. Isn't that interesting? As I said, there are many ways to accomplish the same thing. You probably just want to use the tools that you're familiar with. In this case, we're using JS Loose, and we're executing a query against that AST in order to match strings, essentially. Now, there's one little trick here because JS Loose is expecting command line arguments for files to process. It does not read data from standard input, stdin. It's expecting that you are having files specified in your command. So we're just using this little trick to take the pipe data from Piper and make JS Loose think that we're providing it a file. There's nothing more complicated than that. You might need little tricks like that for tools that aren't designed for you to pipe data to. In this case, we do that, and look at that. We get it to work. We're able to extract the string literals, and it works the exact same as the other approach. Now, you can do a lot more with abstract syntax trees. You can do a lot more with JS Loose. These are just little demonstrations to get you going. And it also provides a really easy way to integrate that type of security testing and analysis into Burp. There is also a JS Loose extension that someone has built that calls the tool on the command line. I'll make a separate video for going over this at some point. It is a nice little interface, and it probably makes things a little bit more efficient, but you really get fantastic customization and opportunities to design and deploy something that fits your needs or the needs of the test that you're doing when you're using Piper to specify the commands yourself. So that's it for this demonstration, just looking at some JavaScript analysis, some more complex things that you can do with Piper, and in subsequent videos, we will continue to look at the interesting things that you can do with Piper.